Let us say I have a body which is a lantern which is fixed on a deck The deck is supported by a jacket. And the jacket is resting in the seabed by some pile foundation. Of course, the jacket has got bracings and battens. Let us say this is my mean sea level. This is my wind direction. And this height is 10 meters, and the diameter is 3 meters, and this is the deck. The deck is 15 meter by 15 meter, and the height of the deck is 4 meters. So, what is asked in this question or the example is determine the total wind force F acting on the deck and a derrick column. Assume basic wind speed with gust. So, gust factors multiplied as 70 meter per second. What is asked is locate the resultant of the wind force for two cases. For 1, sustained wind speed acting constant over the entire height. 2, wind speed follows API spectrum. So, let us say solution. For the first case, wind speed is constant, for the complete height. We know that force because of wind is given by half rho CD, rho of wind CD u z square and the projected area. Let us say for a rectangular deck, the drag coefficient is 1.5 and we already said take UC UZ as 70 meter per second, and area projected, if you look at this figure, deck is 15 meter by 4 meter. So, I should say the projected area will be 15 meter. So, this is the projected area. So, it is going to be 15 meter by 4, which is 60 square meter, and we know density of wind, we already said that 1.225 kg cubic meter. So, that gives me FW as half 1.225 1.5 70 square into 60, which is so much kilonewton. This is A, this is on the deck. Now, on the derrick, being circular, CD is 0.75 and area, if you look at this figure, diameter is 3 meter, height is 30 meter, sorry 10 meter. So, area is going to be 10 into 3, 30 square meters. So, FW is going to be half 1.225 into 0.75 into 70 square into 30, which gives me 67.528 kilonewton. The total wind force is summation of these two, which is going to be 337.641 kilonewton. So, let us say we want to find the moment caused by wind. So, we already have two objects, one is the derrick, other is the deck. CG of the deck is somewhere here, CG of the derrick is somewhere here. We know this is going to be 2 meters because this is 4 meters, and we know this is 10 meters. Therefore, this is going to be 5 plus 4, 9 meters from this bottom. So, the moment due to wind is going to be 270.113, that is on the deck, into 2 meter plus you can see here 67.528 into 9 meters, which is 1147.978 kilonewton meter. I want to find the location of resultant from the base of the deck. I can say that is equal to moment by the total force, which is 1147.978 by total force is 337.641, which gives me 3.4 meters, which is somewhere here. This is the point where the resultant or the force is acting. Let us solve this problem using API code as well. So, B using API wind velocity profile. We already given the governing equation for the spectrum. AP wind velocity says u at any z will be given by u z 0 z by z 0 1 by n where u z is the mean wind velocity at height z above the mean sea level, u z 0 is wind velocity at reference height z 0, z 0 is the datum which is generally 10 meters above the mean sea level, and n actually is an index. This index depends on sea state, distance of the structure from the coast, and averaging period for the wind. Usually 1 by n is 1 by 13 for gust wind, it is 1 by 8 for sustained wind in open sea. In the specific problem we have been asked to include the gust effect, therefore, we will take this value as 1 by 13. So, in that case u z will be given by 70 z by 10 of 1 by 13, because 70 is the mean wind velocity in meter per second. Now, I want to calculate this for the deck. For the deck at its CG, let us say this is my derrick, this is my deck which is supported by a system, and this is my mean sea level. Let us say this is the datum, we say it is 10 meter, and we already know this is 4 meters and this is again 10 meters. In that case, for the deck at its CG, z value will be 10 plus 2, which is 12 meter. Therefore, u z is going to be 70 into 12 by 10 raised to the power 1 by 13, which gives me 70.989 meter per second. So, wind force is half rho C D u z square projected area, which is half into 1.225 into 1.5 into 70.989 square, and the projected area remains same as we worked in the last case, which is going to be 277.799 kilonewton. Now, B for the derrick, Z is going to be 14 plus 2.5, because we want to divide this into 2. So, I take this as derrick as 2 objects, this is one, this is the other, this is my deck, which is 4 meters, and I divide this as 5 meter and 5 meter. I call this as FW2 and this as FW1, and this is going to be 2.5 and this my MSL which is 10 meter. Therefore, Z is going to be 10 plus 4 plus 2.5 which is 16.5 meter. So, UZ is going to be 70 into 16.5 by 10 to the power 1 by 13, which I get as 72.749 meter per second. Therefore, FW1 will be half rho CD VZ square projected area, which is half 1.225 into 0.75, that is cylindrical, 72.749 square multiplied by projected area is going to be 3 into 5. 3 is the diameter and 5 is the height, which gives me 36.468 kilonewton. Similarly, for the second piece, Z2 is going to be 10 plus 4 plus 5 plus 2.5, which is 21.5 meters. So, again use Z 70 21.5 by 10 1 by 13 74.246 meter per second, and FW2 is half into 1.225 into 0.75 into 74.246 square into 3 into 5, which gives me 37.984 kilonewton. Now, the total wind force is 277.799, that is the deck wala, plus 36.468 plus 37.984, which gives me 352.251 kilonewton. I want to now work out the moment. Moment about base of the deck is going to be 277.799 into 2, that is the deck wall, plus 36.468 into 6.5 plus 37.984 into 13.5, which gives me 1305.42 kilonewton meter. Therefore, Y bar CG is going to be M by F, which is 1305.42 by 352.25, which is 3.706 meters. This as a reference, you can refer also to D.V. Reddy and A.S.J. Swamidas, Essentials of Offshore Structures, CRC Press. So, friends, the resultant of this is 3.706, whereas in the earlier case this was 3.4. So, one can try to plot this in this figure. So, in the first case it was from the deck, we plotted this already here, and 3.706. I should plot this slightly. Let us say this is my derrick, this is my deck, one CG and another CG. This is because of API, this is because of constant. That is how it can be computed. So, the problem clearly explains how to use API code as well as constant value for estimating the moments and resultant due to wind. So, friends, in this lecture we learned equation for different wind spectra. We also learned the average gust factor, which can be used to convert the include the gust factor in the velocity component. We also did a numerical example. We also plotted different wind spectra and understood the difference and variation with respect to the force. Thank you.